This videotape presentation covers the total procedure for tuning Weber twin carburetors, from the time the customer's car comes in until it's ready for road testing. It is, if you like, a service action plan. Developed by the Service Training Centre of Chrysler, United Kingdom Limited, the program has been built around a careful study of twin carburetor tuning. The purpose of the presentation is to lay down a plan for the correct method within a practical service time, cutting out the problem of backtracking. Broken down into 4 sections, the program lists the factors governing the correct conditions before tuning, describes the operating principles and common problems, explains the required carburetor checks, and finally their adjustment. The program will be run right through once, then rerun, at which time the tape will be stopped after each section, and any queries can be discussed with your instructor. To aid you with your practical work, a memory aid card will be handed to you after this presentation. Keep the card. It's your own personal aid, and use it when the first few tuning jobs come your way. The presentation will now start. When asked to carry out a twin tuning job, it's important that you do not assume the correct conditions. That is, the other elements that affect the engine's performance are operating to the right standard. Make sure that a correct analysis of the owner's complaint has been made, and do not overlook the importance of stage-by-stage fault diagnosis before starting tuning. It's stage 1 of any action plan. Don't waste your time trying to compensate for other faults. You'll also save time by starting the job with the correct basic tools. The requirements are twin tune or synchro check, volts ampere tester, compression gauge, tack dwell tester, strobe lamp, and pressure gauge. To obtain the very best results, use an engine analyzer. This is the latest dealer-approved equipment. It has a program of tests linked to a simple rotary switch, so that each test is carried out in the same sequence as they appear in the test record sheets, making the equipment a quality checking device for all routine service work. Whether you use the engine analyzer or your range of basic tools, the first diagnosis should be for correct engine compression. A variation of more than 10 to 20 pounds will not do. Incidentally, if you find any of the correct condition checks show defective parts, do not work on them before letting the foreman know. In checking engine conditions, many people underrate the importance of balanced breathing. So check that tappet clearances are correct. If they've been closed unduly, there is danger of loss of compression. On the other hand, too wide a clearance will restrict full breathing, especially at high speeds. Valve timing also needs to be right. Check the engine for all air leaks. They affect idling or just above. The most likely areas are worn valve guides, manifold, and cylinder head points. Check and clean the ignition system. And using a meter, check the dwell angle. The dwell meter is a more accurate method of indicating contact pointer gap, because the dwell can be checked throughout the engine speed range, and take into account erosion of the points, which may not be serious enough to warrant replacement or refacing. Using an independent strobe lamp and tack dwell meter, test ignition timing at 1000 and 3000 RPM. Check the fuel pump pressure using the manual or latest bulletin for the correct figure. Dirt or leaks in the system could create intermittent starvation symptoms. Finally, check the exhaust system for air leaks and internal collapse, which would cause poor engine breathing. Obstruction of flow of exhaust gases, whatever the basic cause, prevents efficient breathing by limiting the inflow of the next induction stroke. The next power stroke suffers, and so does engine performance. Weber twin carburetors make an impressive display and are often the pride and joy of the car's owner. They are in fact quite simple. Think of them as 2 identical units. and each unit has 2 individual carburetors, giving you 4 carbs, 1 for each cylinder. Each unit has twin throttles and shares a common float chamber and accelerator pump, both units sharing a common airbox and cleaner. A sectional view of an individual carburetor shows the operation of the idling and progression circuits. The slow-running jet assembly meters fuel from the float chamber, combines it with air, and passes it along to the mixture volume screw, which is on the engine side of the throttle valve. It's this circuit to look at if there's a problem at idle or very light acceleration. The main jet assembly emulsifies the fuel and discharges it into the small venturi for all power requirements. At wide throttle openings and high speed, additional fuel is drawn from the accelerator pump jets. To gain access to the idle and main jets, unscrew the wing nut on top of the float chamber. This removes the jet inspection cover and the float chamber air vent. Without further dismantling, you have access to the 2 slow-running jet assemblies and the 2 main jet assemblies. The slow-running jets, they're the ones with the solid screw, come out as one piece and are made up of the jet holder and jet. They are a push fit together and may be quite tight. The main jet assembly is larger and is made up of 4 parts: the emulsion tube holder, the air correction jet, the emulsion tube, and the main jet itself. It only requires the removal of the tube holder to check that the air and main jets and the emulsion tube are to specification. If you have to use pliers, be careful not to loosen the fit or to damage orifices. There is one point to check in the accelerator pump circuit. The accelerator pump outlet valves are in each case a free ball and weight. Check that both ball and weight are in place. They're under these screws. If one or both is missing, it would result in a very rich mixture in mid-range operation. The carburetor is very well protected against dirt entering the various jets and circuits. First by a filter immediately above the float chamber and needle valve, and secondly by a very deep float chamber and well. Do not blow out circuits with an air line. The carburetors are secured to the manifold by a flexible mounting. This movement must be there. Its purpose is to prevent excessive aeration of the fuel due to vibration. Some manifolds have been fractured due to these mountings having been locked up solid. The flexing is provided by 4 O-rings in the manifold face, with double coil spring washers under the fixing nuts. The correct condition is flange faces parallel and nuts tightened so that the correct gap exists between the washer coils. The O-rings are reusable if they appear visually sound and fit into their locating recesses easily. But remember, they provide the important airtight joint at these points. The double coil spring washers must always be renewed whenever they're removed. Access to the lower mountings is not easy. The way to do it is to tighten nuts evenly. Set the gap on the accessible ones to the correct figure. Tighten the inaccessible ones to close the coils, then release each between 1/4 to 1/2 a turn. The flanges must be parallel to each other and at the right setting. The airbox between the air cleaner and the carburetors provides a common source of clean air upon which all 4 venturis can draw. This is only satisfactory if the air cleaner is clean and the airbox is airtight. Large air leaks cause cross currents, which form a barrier to even breathing between cylinders, mainly at idle and in particular during the progression stages. The most common cause of flat spots is a gasket that is not sealing properly. A new gasket should be fitted, or alternatively, salvage the old one by cutting at 45 degrees to remove a small section, and then firmly attach the ends with jointing compound. The throttle valves of these carburetors are carefully set up in course of manufacture and run on ball bearings. It is not intended that they should be adjusted in service. Leave well alone. The slow running speed adjustment screw is located on the front carburetor. If a second were fitted, remove it. It is not required and will only make adjustments difficult. The carburetor checks should start by testing the float level and movement. It will need adjusting when new parts, needle valve or float, etc., have been fitted, or when investigating a carburation fault. A hardwood gauge can be made up to check float level. The dimensions are given in the workshop manual. With the float chamber in your hand, see that the float moves easily, and that the float lever contact area with the needle valve is free from pitting. Then check the float weight, which is stamped on the float lever with the figure in general data. Check that the needle valve is tight in the float chamber cover. See that the ball end of the spring-loaded damping device is free. To do this, hold the cover so that the float hangs down. Then tilt the cover and you'll see the weight of the floats will gently close the needle valve first, and then the ball end should recede into its housing. To check the float level, hold the cover vertical with the gasket in place so that the needle valve is closed, but without moving the ball. The high point of the main body of each float should just touch the gauge when it is inserted. The soldered seams of both floats should be over the cut-out portions of the gauges, as shown in the workshop manual. If the float level is incorrect, adjustment is made by carefully bending the tab which the needle valve works on. It must be kept square. Bending away from the cover raises the float level. The amount of bending is very small, so don't overdo things before rechecking. When float level is correct, float movement or drop should be checked using a steel rule. The cover is now held horizontally so that the floats hang down. The measurement is made between the gasket face and the highest point of each float, ignoring the soldered seams. It pays to make a minimum adjustment and recheck until the correct figure is reached. Adjustment is made by bending the tab that bears against the needle valve body with the float removed. Adjustment of the twin choke control cables is straightforward. Release cables at the carburetors. Set control knob to about 1/8 of an inch out from home. Check that both start device levers are hard against their backstops, then tighten the securing screws. To check operation, pull the choke control out fully and check both starting device levers are hard against their front stops. Then push the control fully home and ensure that both levers are now hard on their backstops again. Adjustment of the throttle control cable at the carburetor end consists of ensuring that both correct idle and full throttle can be obtained at the carburetors. So check that the correct slow running speed is obtained with the throttle pedal released, and that the full throttle opening is obtained when the accelerator pedal is held to the floor. This ensures that the cable is not overloaded under full throttle road conditions. The adjustment of the outer cable is at the carburetor end. If there is a failure to obtain full throttle opening, check that there is no obstruction of the pedal by additional mats. Before starting the engine, screw in each of the 4 mixture volume adjustment screws down lightly onto their seats. Then back off each by half a turn. Now start the engine. If necessary, adjust the throttle stop screw on the front carburetor to allow the engine to run at a fast idle. The engine must now be allowed to warm up until coolants and lubricating oils reach their normal operating temperature for all the adjustments that follow. Whilst the engine is warming up, check that the twin tune has correct rubber plugs, orifice set and damped gauge fitted. The orifice sets are color-coded to engine capacity and the gauge face is marked with a D at 12 o'clock. Connect a tachometer and adjust the throttle stop screw until the engine runs between 1000 and 1200 RPM. Assemble the twin tune throttle barrels numbers 2 and 3. The gauge reads both barrels at the same time, and the needle swings according to which applies the greatest depression. To balance the carburetors, adjustment is made at the throttle synchronizing screw, which adjusts the setting of the rear carburetor relative to the front. So work to the B instructions on the gauge because you will have the B orifice cap in the rear carburetor. If adjustment produces a marked increase in engine speed, reset to not more than 1000. Recheck and replace the airbox. When balance has been obtained, a fine adjustment of the mixture volume screws can be made against the highest obtainable reading on the tachometer. Starting at number 1 mixture volume screw, adjust to obtain the highest reading on the tachometer. The engine may now be in excess of 1000. Return the speed to 1000 before proceeding to adjust number 2 volume screw, which is treated in a similar manner, remembering it is necessary to return the engine speed to 1000 RPM before going on to numbers 3 and 4 cylinders. The engine will now be running at 1000 RPM, but further fine adjustment of the volume screws will be necessary. This means starting at number 1 again and working through each cylinder in turn. If the job has been done correctly, disconnecting each plug in turn should produce the same fall-off in engine speed, but do allow full recovery between each plug. The twin tune equipment is very accurate, has the facility to balance over a wide range of engine speeds, and is very easy to use. The synchro check is an alternative instrument, which measures airflow at only one throttle barrel at a time, but is used in the same way as the twin tune with the engine at full normal operating temperature. The initial procedure to get engine to run and warm up is the same as already described. With the tachometer connected and the engine running between 1000 and 1200 RPM, compare the airflows of number 2 and 3 throttle barrels. The individual readings should be the same. If they are not, turn the synchronizing screw clockwise to increase or anti-clockwise to decrease the reading from number 3 barrel. During this adjustment, the engine speed should be maintained at approximately 1000 RPM by altering the setting of slow running screw. When synchronization of the throttle has been obtained, refit the airbox, making sure that the gasket is sealing correctly, and then proceed to adjust the mixture volume screws in the same sequence described for the twin tune unit. The car is now ready for a road test to make sure that the progression stages are working smoothly and that there are no flat spots on light acceleration. Stick to your action plan. Check engine condition, ignition, fuel supply and exhaust breathing. See the carburetor is clean and to specification, and if adjustment is necessary, check float levels and choke and throttle controls. Then your synchronization and slow running adjustment will work out. Just one last word. Please use your workshop manual. They're written and printed specially for you. A few minutes reading can save hours of frustration if you have a problem. And reference to general data and bulletins ensures you are using the correct, up-to-date settings for the car you are working on. This presentation is now finished, and after a short break, it will be rerun for you to ask any question you may have. After the questions have been dealt with, we will be transferring to the workshop to demonstrate in practical terms how the tuning stages are carried out, during which time you will be able to join in with the activity.